Okay, so we've got another derivative problem. And so the question is to find the derivative. I'm just going to abbreviate it. Find the derivative of f of x is equal to x squared at x is equal to 2. Oh, no, sorry, I read the wrong thing. Let's make that -3. At x is equal to -3. So find the derivative of f of x is equal to x squared at x is equal to 3. So this is a derivative problem, and they're asking me to find the derivative at a specific point. So yeah, so it's useful for me I like pictures. So whenever I see a question or problem, I try to visualize what is the picture that goes along with that problem. And so the idea here is that we've got a parabola. So we all know what the graph, we should all know, oh well. We should all know what the graph of f of x is equal to x squared looks like. It looks like a parabola. And then here's a point on the parabola. And we're going to say it's the point where the x coordinate is -3. And if you think of, here we go. I want to see if you're paying attention. What's the y coordinate of this point going to be? So in the chat or on the microphone, can someone tell me if this is the graph of y is equal to x squared, if x is equal to 3, what's the y coordinate going to be? All right, good. Someone in the chat told me correctly that it's going to be 9 because you just put -3 into the function and you get 9. Okay, so all right, so we got this point, and now I can imagine drawing the tangent line. So if I imagine drawing a tangent line, so the line that just kisses the curve right at that point, is pretty terrible drawing, I apologize. But we'll make this a nice big point so it looks like a tangent. If I imagine drawing a tangent line, what this is going to tell me, this question, our answer, when we answer this question, what it's going to tell me is it's going to tell me the slope of that line. So right now, I don't know what the slope of that line is, but I claim that this is going to be the answer. Okay, but anyway, there's your picture. And so I guess in some sense you didn't have to draw that picture, but I like to draw the picture because to me the derivative means something. The derivative isn't just a meaningless exercise that I go through because my calculus teacher wants me to. To me, the derivative means something. And what the derivative means is it means the slope of the tangent line. And so I don't know what the slope of this line is. It's pretty hard, but this derivative will tell me. Okay, so let's do it now. Okay, so all right, so we're gonna compute the derivative at x is equal to 3. So the notation for that is f prime of, oh wait, I keep saying 3, but I mean to say -3, sorry. So we're going to compute the derivative at -3. And okay, and what's the definition of that? Okay, so the definition of the derivative is it's the limit as h goes to 0 So this is good. We've seen that before. The derivative always starts with the limit as h goes to 0. And then what you have in the numerator is you have f of negative 3 plus h minus f of negative 3. And then you divide by h. So the idea here is that since we were finding the derivative at the specific number negative 3, then the negative 3 is what gets plugged in to the formula for the derivative. So if you look at, so again, this is why it's important to look at examples. The more example, it might seem kind of random what I'm doing here. But if you look at the examples, if you watch the videos, you'll see a pattern. You'll see a very clear pattern of what gets plugged in where. And so the pattern is very consistent, and you just have to learn that pattern. Okay, so this is the definition of the derivative at negative 3. And so now what I have to do is I have to simplify this limit. So I say, all right, so I've got the limit as h goes to 0. And so I say, well, okay, what the heck is f? Okay, well, this is where I have to go back to the original definition, the original problem. Oh, f was the squaring function. So, okay, so that means that f of negative 3 plus h is going to be negative 3 plus h squared, right? F is the squaring function. So whatever you put into f, it just gets squared. And then we minus, oh, this will be 9. Because when you put negative 3 into the squaring function, you get 9. And then you divide by h. And also you might have noticed, hey, we got a 9 here when we drew the picture, and we also got a 9 here. And that is not a coincidence, because 9 is what you get when you plug negative 3 into the function, and plugging negative 3 into the function is what we're doing here. So that's not a coincidence. In mathematics, there are coincidences in mathematics, just like there are every place else. But a lot of the things that happen in math are not coincidences. So if you see something that looks like it's following a pattern, it might be. No, there's no guarantee, but there might be some interesting pattern there. So it might be worth exploring. All right, okay, but I'm getting off track here. Okay, so all right, so let's see now what we got here. Okay, let's do FOIL. So let's do FOIL on this, right? Because you got to do FOIL. So this is going to be the limit as h goes to 0 of, okay, so negative, because right, I hope it's making sense what I'm doing here. Let me write it off to the side here. Negative 3 plus h squared, that's the same. What that means is negative 3 plus h multiplied by negative 3 plus h. And that's why I said you have to do FOIL, because you got to do this guy times this guy, and then you got to do this guy times that guy, and then you got to do this guy times that guy, and then you got to do this guy times that guy. You got to do, you got to do the usual FOIL thing. So, all right, so okay, so when I do negative 3 times negative 3, I get 9. And then when I do a negative 3 times an h, I get negative 3h. And then when I do h times negative 3, I get another negative 3h. And then when I do h times h, I get h squared. And then don't forget about the minus 9. So actually, maybe I'll put this in parentheses for emphasis. again, the parentheses I just put there are not strictly necessary because everything here, there's nothing that's nothing's being multiplied or raised to a power or something that everything, all the terms here are just being added or subtracted. So you don't really need these parentheses, but I kind of like them because it makes it clear to me that this turned into this. Okay, so now let's see what we got. I think we got some cancellations here because we've got, here's a +9 and here's a -9. So those guys can knock each other out. And then, so then what we've got is we've got the limit as h goes to 0 of, okay, I'm going to go ahead and do a simplification here because you got a -3h and another -3h. So that's going to make -6h, right? Because if I have -3 h's and then I subtract another 3 h's, that means I'm 6 h's in the hole. And then you got, but then, okay, and then also don't forget that there's the h squared. And then divide by h. Okay, almost done. Almost done. Oh yeah, that's right. I forgot. Well, no, okay. I've got good news. I've got bad news and good news. So the bad news is I forgot to do something. The good news is it doesn't really matter. I didn't make a mistake. There's nothing wrong with what I did, but I forgot to follow my own advice. And my own advice was, remember, you should before you do anything, you should always try plugging in the number. So back here at the very beginning, we should have tried plugging in 0 for h, just because maybe we'd get lucky. And now it turns out we don't, because if you plug 0 in for h, then you will get 0 over 0, and that is not an answer. So, all right, so good for us. We forgot to do something, but it turns out it wouldn't have helped anyway. But now now that it's simplified, I should try it again. I should try plugging in h is equal to 0. But unfortunately, you can see that if I try plugging in h is equal to 0, it still gives me 0 over 0. So that's bad. But what that tells me is there's more simplification to do. So if you're ever wondering, Travis, how do I know when I've done enough simplification? The answer is, can you plug in the limit number and not get 0 over 0? If you plug in the limit number and you get 0 over 0, then that means there's more simplification to do. So, all right, so there's more simplification to do. And if I think about it a little bit, I can see that, oh yeah, I can factor out an h in the numerator. So if I factor out an h, then I get a -6 plus h. And then I have an h in the denominator. And now I can see that there's a cancellation. This h can knock out this h. And now now let's try plugging in 0. If I plug in wrong thing, wrong tool. If I plug in 0 now, I get a number. I just get -6. Well, maybe I'll write -6 plus 0 for emphasis, but that of course is just -6. So that's my derivative. So so that was a lot of work. But yeah, derivatives are a lot of work. But the good news is we'll get some shortcuts eventually. We'll get some shortcuts that will make this a lot faster. Oh yeah, and we should do a reality check. That is that we should do a reality check of, did we expect to get a negative number as an answer? And I would say yes, because when we drew the picture, we said that the derivative should be the slope of this yellow line. And does it make sense for the slope of that yellow line to be negative? And I would say, yeah, it better be negative. We better have gotten a negative answer. All right, so a good question came up in the chat. So if you have to go, I understand it's 9:50 now. So obviously, if you need to check out, you can do that, and but you can always come back and watch the video. But I do want to answer this question. So, because it is a very important question. So let me see here. Let me erase this because I don't think we need it. So the question is, so the idea here is, yeah, that f prime, the derivative, we said the derivative was this formula. So so f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a divided by h. So that is the definition of the derivative, and that is, you should have that definition memorized. You're going to use that all the time. Okay, but there's another definition, and it's this one. It says f prime of a is the limit as x goes to a of f of x minus f of a divided by x minus a. And so at this point, you should say, I'm confused. You should say, well, which one is it? Which one is the correct derivative formula? Is it the one with the h's, or is it the one with the x's and the a's? And the answer is, mathematically, these are exactly the same thing. So what you could do is you could go through and do this whole problem again using this formula. And if you did it correctly, you would get a -6 as your answer. So the moral is that these two formulas are exactly mathematically the same. And so the question is, well, which one should we use? And the answer is, you can use either one. It makes, as long as you use them correctly, it makes no difference which one of these you use. So personally, I'm going to use this one most of the time because this one to me is the easiest one. But you might disagree. You might like this one. And if you like this one better, then you are 100% welcome to use this on any derivative problem. If you use it correctly, you will always get exactly the same answer that I did using this formula. So there, and you might say, well, wait, why are there two formulas? That's confusing. Well, some people say it's confusing. Some people say, no, it's good because now you have flexibility. You've got freedom. You can use this formula if you want, or you can use this formula. So don't think about it as confusing. Think about it as liberating. You've got freedom to use either one of these formulas. So I hope that answered your question. So it just kind of just be aware of that. So the fact is, if you want to be if you want to get a grade of an A, you probably should have both of these memorized. So if you want to be a true expert in calculus, you should remember both of these formulas and be able to use either one. But if you want to keep things as simple as possible for yourself, then you probably only need to memorize one of these. And this is the one that I am going to use most often in class, and this is the one that gets used most often in the book. So this, if you're only going to remember one, this is probably the one to remember. All right.